Okay, so now I'm just interested to see how you would prove the square root of 5 is irrational.
Well, let's see, we'd have to use a similar technique. We'd have to write it as a over b, just following the same way as the square root of 2, squaring both sides, a squared over b squared, and then writing it 5b squared equals a squared. And this is, I guess this is maybe where we could get stuck a little bit, but maybe not, because this shows that a squared is divisible by 5, so a is divisible by 5. A is divisible by 5. Then we can write a as 5 times some x, so 5b squared equals 5 times x squared, so this equals 25x squared. Dividing on both sides by 5 gives you b squared equals 5x squared. So you know that b squared is divisible by 5, so you know that b is divisible by 5. And so by following the same method as we used for the square root of 2, we just showed that we can divide out 5 from both a and b.
Okay.
And again, we assumed they were in lowest terms at the beginning, so that assumption is wrong and we can't write the square root of 5 in this way.
Okay, very good. So I'm curious, after this proof, what kind of integers do you think the idea that you've used here for 2 and 5, or square root of 2 and square root of 5, I guess, being irrational, what sorts of integers do you think this proof will work for?
Well, maybe primes. It could work for primes.
Okay.
Because maybe if you used non-primes, you could run into some more difficulties doing this. And also some primes are squares, so you could get stuck there.
Some primes are squares?
Some non-primes are squares.
Oh, I see. Right. Okay. Yeah. Yeah. Okay. So I think this would definitely work for primes. I think it might. This general idea might work for a broader class than that too. But certainly for primes, that's a good observation. But now I'm going to do a little twist on the square root of 5 proof, following the square root of 2 proof also, and we're going to see something pretty interesting.
All right.